Rx little stream I've got going here. Once again, this is me, Matthew Podwasaki, aka Lambda Calrissian, aka Bluer Than Blue Falcon. So today I wanted to also show off the nice shirt that I've got going here, which is the Chloe Condon shirts that I happen to pick up off of Custom Ink for supporting the Girls Who Code effort after the whole situation with the Instagram stalker and all of that good stuff. I decided to do the best I could to support the community through supporting things that I think are very worthwhile, such as Girls Who Code and other things. And I'll also be supporting Black Girls Coding because of the whole situation where this one guy is trying to shut it down because of its discrimination. So once again, we have to find organizations like this that are worthwhile and promote diversity and inclusion within our space. So, needless to say, we've got a bit of covering of things that we've been doing on Rx. So I wanted to go back into that very briefly about where we've gone so far with this adventure. Now, note today that we're not necessarily going any further with our solution. Because I wanted to take a quick little break and look into the ideas of its sister library, RxJS, and take a look through there. So once again, if you just go to github.com/reactivex, RxJS Advent of Code, has all of the samples that we have here, and I'll add in the IX samples as well. I think they're very worthwhile to do here. But what exactly am I talking about when I'm talking about the interactive extensions for JavaScript? Well, what I mean by that is that we've got the reactive extensions for JavaScript, and that covers such things as events over time, or discrete objects over time. But that's truly in a push style and not much in between. But if you're looking for other ways about iterating over collections, there are different ways of thinking about it. There's both the interactive and then there's the reactive side of things. The interactive is what I would call the pool-based semantics, which is something like an array or an iterable in JavaScript, whereas then you have these kind of hybrids as they've come along, which is, you've got iterable, which came along with ES 2015. Then you've got generators as well, which are also iterables, maps and sets, also iterables. And then later along the line, what we've got is async iterables, which I think is much more interesting in terms of the things that you can do. For example, now I can talk about things like files and other I/O pieces that are fairly heavy to lift and allow for back pressure. Those are the kinds of things that we'd want to do with an async iterable, meaning we'd want to pool the data as we can over time. Now, this differs, of course, from reactive extensions, where you subscribe to, say, if I subscribe to a file and just started shoving data at it, then I might have a little bit more of a problem. And so that would be definitely problematic if I happen to do that. If I happen to open up 2, 3, 4 gigs of a file and start iterating over it, the consumer could obviously get overwhelmed with that. So that wouldn't be very cool. That would be kind of tragic in that suddenly you're taking gigs upon gigs of data and throwing it throwing it at the consumer probably faster than they can handle one of these files. Instead, what you're going to want to do is you're going to want to talk more about the iterator pattern and pooling data as it becomes available. So let's start to look at that. What we can do with the iterable class. So as you'll see, a lot of this code in these examples are much more older style of of RX5.x style of code, and the updates are coming to make this more of an RxJS 6 style with piped operators and so on and so forth. But the basic gist of it is that we've got this way of dealing with arrays, maps, and so forth in such a way that we can do map and filter and reduce and so forth. And we can then go over it with map, and we can either add operators just as we did here, more as the style, like I said, from the RX v5 time frame, but we can also do the style of bringing them in kind of as functional. Functional programming things where where the source is first. You can do it that way, or we can actually bring through and bring in the pipe and do it that way in terms of I can bring in filter and map and do it that way. What we're going to do ultimately is condense all of these into one single way of doing that, which is more along the lines of this particular style here, which is we can get the iterable and then we can get map and filter and then pipe through it. So that's kind of cool in the fact that we can be productive pretty quickly. So let's actually go through and take a look at some code to get started. So if I said const it is let's say iterable.of 1, 2, and 3. So what does it have in it that makes it interesting? Well, since I brought in all of IX, it happened to shove every possible operator that there possibly was onto this, instead of pulling over only the things that I needed. Like I said, in the newer style. But the thing that's more interesting is the contract behind an iterable itself. And to do that is we can get the iterator. So this is the iterable here. So if we can just say iterable is that, and then we can say const it for the iterator, and so we can say iterable and symbol dot iterator. And what that does is that gives us the contract, which is very analogous to RxJS in terms of being able to iterate over a piece. So we can say it dot, and they have three particular things here. One being next, which gives us what? It gives us our next value. Comes back with an iterator result. So we can say that result equal to it.next. Now result will now have the things of value and done. So we can say dot done. Okay. So we can console log each, running through each piece and showing you what it does. So every time you call that npx 23 npx ts-node 23 index.ts, and what it'll do is it'll go through and it'll say, okay, the first value is 1 and the result is done. So you can keep on going and iterating over it, calling next, calling next, calling next, and it'll keep on going, and we can keep on going here until it's ultimately done. And running it through now will show us that we get 1, 2, 3 false, and then undefined and done is true. So that's very interesting in the fact that we keep on going and pooling values until we're ultimately done. So that's basically the idea behind iterable is a way to generalize maps, sets, etc. So for example, if I took iterable here on line 3 and change it to array.from or something, or just even 1, 2, and 3 and 4, 1, 2, and 3 here, I'll get the same result, because once again, in the new versions of the ECMAScript spec, the array itself implements this symbol.iterator. And the same can be said of a new, say, a new set, and we'll give it the values of 1, 2, and 3 that we did here before, and we'll get basically the same value all over again. So cool. That's the basic idea of going through there and doing this. Now, we can also, instead of using this iterable here, we can create a generator. So so let's create an iterfn, and how we manage to declare what a generator function looks like is we add this little star here. Now this star basically sets that apart and says it is a generator function, which then supports this yield construct. And this yield construct allows us to do yield 1, yield 2, and then yield 3. So that, but what could also happen is I can do things like return 42 as well after the fact. And how that changes things is fairly interesting, and yet kind of weird in its own way, in that we can go through and I can now call it on my iterator function, instead of the way I did here. And what you'll notice is that it says that that this particular construct is done, in that it's saying true here as it's done, but at the same time it gave us a value of 42, which, say, arrays didn't, sets and maps don't give us, but generators do. Now that's kind of interesting, I think. Now, what we can also do is, now that we kind of know how we can generalize all of these kinds of things, what's the great thing about iterables, and in particular IX, is the fact that we can generalize over all of those. So going back and looking at some of the code that we had here, we can bring in some of these operators, such as pipe and or map and filter, if we chose to do so. So if we've got that, now we've brought in the iterable, we can also then import map and filter from, and then we've got this particular thing here. So if we wanted to pull in specific operators, now we can do so. So let's go ahead and take this this iterable that we have here, this iterable that we have, and create a proper IX iterable from its const. We'll call this IX iter, and we can now say iterable.of, or rather as. And now as, what that does is it takes any source that we have and turns it into our iterable. So if we said iterable here, that now works. And now what we can do is we can then say ix iter, result. Now we can say ix iter dot pipe, and then we can say map and do our normal mappy things that we want to. X mod 3 is equal to 0, and so on and so forth. So what we get is we get this result here. Let's comment out this stuff down below. And now what we can do is we can call things like, we could say result dot for each, and then say console.log. And that will go and it will iterate the construct, returning back the at the 0 and at the log of 0, or rather at index 0 we have the value of 9. So kind of cool that we can do that. Now, what IX also provides is since they are just iterables and it implements the iterable contract just as anything else does, we can go ahead and for of on it. So if I said for let item of result, console.log item, we now have a fully functioning capability of going through and just treating our IX iterables as if they were normal iterables. And then we could also take this function here, this iter function, take it up here, and use that, turn that into an iterable as well, and run it through. So really, really cool is the fact that we get a lot of these syntactic things directly from the browser for free, in the fact that in the browser and the runtime basically for free, in that we now have a way to standardize, to iterate, to map, filter, do whatever we want to. So that's really, really cool. And you can think of this as Lodash or any other of those iterator-based or Ramda or any of those other libraries. But IX goes a little bit further in one of a couple of places. The second place where it starts to get interesting is when we're talking about, say, async iterables. Now, async iterables are a little bit different in that we can start off with an async function, for example. So an async generator, and iterate over that. So let's do that real quickly. So if I said const, let's create a function here, async function star of well, let's say we'll call this async yielder. Okay. All right, cool. So what can we do from here? Well, we could yield one. What we could do, as we did before, what we could also do is say yield promise dot resolve 2. So it means we can await something and return it through as part of this thing. And then we could also do yield promise dot reject if we want to do a rejected promise as well. And I'll talk about some of the error handling and things like that when we dive deeper into IX further on down the line. But I just wanted to give a brief introduction to IX before we dive back into Rx, just to show that A, the project's alive, and B, it's kind of interesting. Now, when we get this async iterable, what happens? So let's say const AIT, we'll call it async iter, aiter is equal to this async yielder. And now what? So what does aiter have on it? Well, nothing really. It doesn't really get interesting until you say const it is equal to a iter. Now, just as we had the symbol dot iterable or iterator, we have our symbol async iterator here. Now, what does that give us? So, AIT now gives us what? Well, IntelliSense isn't showing us, but I know for a fact, for example, that it gives us a couple of things. It gives us the same contract, although asynchronously, as we had for the iterable. So I can then say let results is equal to await, because remember we need await ait.next. Okay. Yes. All right. So we need to create an async function for this. So we'll just call this async function main and do it there. All right. We'll do it live there. So we'll just run this through, and then we'll just call main. So anyways, what we'll do here, since we don't have top level awaits right here, but that's okay. So then we can say console.log result.done and console.log result.value. Now, then running main, what happens? So what happened was that we got the first value out of this async iterable by first awaiting this next, and then going through and getting that the next value. So what we can do is we can do that again, and again, just to see what happens in terms of iterating over this async iterable, which, like I said, is not only resolving the regular the regular value that we yielded, which once again gets wrapped into a promise, but also that we have these ones that were specifically promises here with 2 and 3. Cool. So now, now that we kind of know this, we can take this async async yielder here, and we can turn that into an async iterable. So const ix a iter is equal to async iterable.as, and we can take our a iter and go from there. And it just says last type signature. That's okay. That's because I'm an idiot, and there we are. Okay. So what we've done there now is we've wrapped that as an async iterable, and we can do all the same things that we did before, which was this ix iter. We can then just call it here and iterate through the results. What's also cool, though, is that we can do all the things that we wanted to do with async iterable with iterable. So just changing this to async iterable pipe and pulling in all of those values. Then once again, we can take this ix iter and then we can do some pipe magic, just as we did before, with the whole map x times x, and then filter on whatever we wanted to. X mod 3 is equal to 0, so on and so forth. So cool. It doesn't seem to know. Okay, it must be type of integer or big num. That's cool. So something here got screwed up just a little bit, but that's okay. It should still just run in terms of. Actually, no, let's give it a number just to make sure that it knows what type it is, and then it should just run through. So it doesn't necessarily know right here, but it should. All right, so doing that and running it through. Okay, apparently I do have an issue here. All right, I'll resolve that next time. But needless to say, the async iterable here, we can still do all sorts of interesting things with maps and pipes and filters and so on and so forth. I'm not afraid to let some bad code just sit around here, but what I wanted to get through to you is that it's really kind of a cool thing that we can basically use any of these constructs that are now part of the DOM, part of the the JS implementation. We can now start to use these things in a very nice, sustainable way. Going back, actually, I forgot one thing, and that's so we had this little example before with our async iter here. And instead of doing that, we have this new construct as well for await, which allows us to basically pull off values from this async iterable. And so, all right, so async iterable. All right, I need to obviously set some settings here, and it will start to behave. I just need to modify my TS config, and we'll like I said, we'll work on that next time when we're more focused on IX related things. But in the meantime, like I said, is that we've got a lot of things to explore here, obviously, with our code. So I do highly suggest that you go back here and you give it a look, because once again, IX is going to be an interesting playground going forward, in the fact that node streams are IX compatible, because node streams are async iterables. But I think a lot of the things that we're doing or can be doing should be more pool based, such as anything IO related. So really, really cool things that we could possibly do with IX that Rx isn't necessarily perfectly handled for things such as back pressure. So take a look at that. You'll and keep an eye on this in terms of, we will bring it more up to speed with how you would use Rx today, and think about some of the use cases that you might run into in the future. But like I said, we've got the async iterable. We've got all the contracts here, just in case you need the documentation on what exactly an async iterable or an iterable is. And then we also have the ability to convert an iterable to an async iterable by providing such things as we also give you the map capability, or map async, flat map async, and so forth. So that you can convert your streams, your iterable streams, into async iterable streams, and so on and so forth. So there's a lot to cover here. I hope that you'll take a look at this and give some feedback. And so next time we'll go back into more Rx things. Go back to share. And share versus publish, and cover that topic. But today, since I was working kind of all weekend on IX and bringing that up to speed, I just wanted to kind of talk about that today. So thank you all for coming today. Highly recommend that you check out IX and keep an eye on us in the future. Just as I created Rx, we created IX to kind of be complementary, not competing with that technology. So stay tuned and give me lots of feedback here on Twitch at Bluer Than Blue Falcon, on Twitter at Matt Pugwaisaki, and catch me on YouTube as well. So thank you so very much today, and I will catch you next time. Bye-bye.